When you first step into the world of RV living, one of the most confusing but also most important things you'll come across is the electrical system. Electricity inside an RV works differently from a regular home, and if you don't understand it properly, you could end up draining your batteries too quickly, damaging appliances, or even creating dangerous situations. But don't worry. Once it's explained step by step, you'll find that it's not as overwhelming as it looks. The key is to know the basics of how electricity flows through your RV. The difference between shore power and battery power, what devices rely on 12 volts versus 120 volts, and how to keep everything safe and efficient. Let's start with the most basic idea. Your RV has two main types of electrical systems, a 12-volt DC system and a 120-volt AC system. The 12-volt DC system is powered primarily by your RV's batteries. This system is the backbone of your RV because it controls your lights, water pump, fans, slide-outs, and sometimes even your control panels and refrigerators if they're designed to run on propane and electricity. On the other hand, the 120-volt AC system is just like the electricity you use at home, and it powers things like air conditioners, microwaves, TVs, and regular outlets where you plug in coffee makers, laptops, or other appliances. That system runs when you're plugged into shore power at a campground, or when you use a generator or sometimes an inverter. Now, think of the RV like a hybrid car that can switch between different power sources depending on what's available. If you're parked at a campground and plug into the power pedestal, that's shore power. Shore power comes in two standard versions for RVs, 30 amps and 50 amps. A 30 amp system uses a three-prong plug and can deliver up to 3,600 watts of power, which is usually enough for smaller RVs with one air conditioner and basic appliances. A 50 amp system uses a four-prong plug and can deliver up to 12,000 watts, which is much more power. And that's why bigger RVs with multiple air conditioners and heavy appliances require it. It's important to know which one your RV is wired for, and always use the correct adapter or connection. Otherwise, you could either trip breakers constantly or even damage your electrical components. When you're not plugged into shore power, your RV relies on its batteries. Most RVs come with one or two 12-volt lead-acid batteries, but many people upgrade to lithium batteries because they hold more power, last longer, and can be discharged deeper without damage. Your 12-volt system is what keeps your essentials running, even when you're camping off-grid, also known as boondocking. But batteries alone don't last forever, which is why RVs also come with converters. A converter is a device that takes the 120-volt AC power from shore power or a generator and converts it down into 12 volts to charge your batteries and run your 12-volt systems. Another important device you'll hear about is the inverter. Unlike the converter, which goes from AC down to DC, the inverter does the opposite. It takes 12-volt battery power and turns it into 120-volt AC power, so you can run household appliances even when you're not plugged into shore power. For example, if you're boondocking and you want to watch TV or use a coffee maker, the inverter is what allows that to happen. However, inverters use a lot of battery power quickly, so they need to be sized correctly, and you have to be mindful about how long you run them unless you have a big battery bank and solar panels to recharge. Speaking of solar panels, many RVers add them to their electrical system for more independence. Solar panels capture energy from the sun and send it into your batteries through a charge controller, which regulates the power so your batteries don't get overcharged. Solar is fantastic for keeping your batteries topped off during the day, especially if you like to camp without hookups. However, keep in mind that solar by itself doesn't power your RV directly. It simply charges the batteries, and then the batteries supply the 12-volt system, or through an inverter, the 120-volt system. Now, let's dive a little deeper into safety, because that's an area beginners often overlook. RVs use a system of circuit breakers and fuses just like in a house, but everything is more compact. The breaker panel will protect your 120-volt appliances from overloading, and the fuse panel protects your 12-volt circuits. If something stops working, always check the breaker or fuse box first. Carry spare fuses with you because it's a common fix while traveling. Another important piece of safety equipment is a surge protector. This is something you plug into the campground pedestal before you connect your RV. Campground power can sometimes be unreliable or have voltage spikes, and a surge protector saves your RV's electrical system from being fried. Let's also talk about grounding and polarity. When you plug into shore power, you need to make sure the wiring at the pedestal is correct. There are inexpensive plug-in testers that show you if the pedestal is wired properly, and it's a smart investment. Incorrect wiring can cause shocks, damage equipment, or worse. Grounding ensures that in the event of a fault, the electricity has a safe path to travel, rather than through you or your equipment. Always take time to check this when plugging in. Another area beginners get confused about is managing electrical loads. Let's say you're plugged into a 30-amp connection. If you try to run the air conditioner, the microwave, and a hairdryer all at once, you're going to trip the breaker because you've exceeded your 3,600-watt limit. Learning how to balance loads is crucial. For example, turn off the air conditioner temporarily while running the microwave, or don't use high-wattage appliances at the same time. With 50 amps, you have much more flexibility, but it's still good practice to be aware of your consumption. A common question new RVers have is, what happens when you drive? While you're on the road, your RV batteries get a charge from the alternator in your tow vehicle or motorhome engine. This helps keep them from running down completely during travel. However, the charge from the alternator is usually not enough to fully recharge drained batteries, which is why many people add solar panels or portable generators as extra charging options. Generators are another important piece of the puzzle. Many RVs, especially motorhomes, come with built-in generators. Smaller campers might use portable ones. A generator creates 120-volt AC power, which can run your air conditioner outlets and charge your batteries through the converter. Generators are noisy and use fuel, but they're reliable and often necessary if you want to camp without hookups, and still use power-hungry appliances like air conditioning. Another concept that often confuses beginners is the difference between parallel and series battery connections. If you connect two 12-volt batteries in parallel, you still have 12 volts, but you double the capacity, meaning the batteries last longer. If you connect two 6-volt batteries in series, you get 12 volts as well, but with a different configuration. Many RVers use 6-volt golf cart batteries wired in series because they tend to be more durable and hold up better to deep cycles. Understanding these options can help you expand your battery bank in the future if you need more power storage. As you learn about your RV's electrical setup, it's important to also learn the limitations. Not everything in your RV can run off battery power alone. For example, most rooftop air conditioners require a huge amount of power that batteries simply can't supply for long without a large inverter system and a massive bank of lithium batteries. For most people, running the AC requires being plugged into shore power or running a generator. It's better to understand this up front than to be frustrated later when the AC doesn't work off-grid. At the same time, you should also understand phantom loads. These are small devices like TV receivers, stereo systems, or even control boards and appliances that continue to draw power even when you're not actively using them. Over time, phantom loads can drain your batteries without you realizing it. That's why many RVers install a battery disconnect switch, which lets you cut off all power from the battery to prevent drain when the RV is in storage or when you want to conserve power while camping. Once you become familiar with the basics, shore power, batteries, inverters, converters, generators, and solar, you'll start to see how all the pieces fit together like a puzzle. It might seem overwhelming at first, but think of it this way. Your RV is like a little house on wheels that has to make its own power decisions. At home, you just plug things in and don't think about it, because the grid supplies nearly unlimited power. In an RV, you're in charge of managing where the power comes from, how much you use, and how you store it. That's both the challenge and the beauty of RV living. The good news is that once you learn how to manage your RV's electrical setup, it becomes second nature. You'll know when to plug in, when to conserve, when to fire up the generator, and how much your batteries can handle. And as you gain more experience, you can upgrade your system to suit your camping style, whether that means adding more batteries, installing solar panels, or upgrading to a more powerful inverter. The most important takeaway for beginners is this: don't be intimidated. Break it down into simple steps. Understand that your RV runs on both 12 volts and 120 volts. Learn what each system powers. Know the difference between shore power, batteries, solar, and generators. Be aware of your limits and always think about safety first with surge protectors, fuses, and proper load management.